how can we make this look like 1 over 1 minus r? Because as soon as we do that, we can write it as the sum n equals 0 to infinity of r to the n. So algebraically, we want to manipulate this to look like this. Well, first of all, to get a 1 on top, what can I do with that 4? Yeah, just make it a factor out front. Well, that's not quite what I want. Let's rearrange this denominator here and make it, let's put the constant out front, kind of like how that 1 right there is out front. So let's make it 2 plus x. And I could easily make that minus, and I will in a minute, 2 minus a negative x. But before I do that, remember, I want a 1 right here. So what can I do to get a 1 right there? A couple of different ways to think about it. In the denominator, could I factor out a 2? Yeah. Well, yes, exactly. So you've seen that trick before. So here, look, if I factor out a 2 from this denominator, then I'll have 1 over 2 times the 1 in the position where the 2 was. That's what I want. And then plus, okay, so take x and divide by the thing you factored out. Remember that trick? And then if you redistributed the 2, you'd get exactly 2 plus x. So you've seen that trick before. And then, good news, this doesn't have to happen, but it's nice. 2 goes into 4 twice. So we get something like this. 2 times the quantity. Now I'm going to write it as 1 over, okay, I'm going to write this plus as minus a negative. So 1 minus a negative x over 2. So a little bit of algebraic trickery. And now I have this form looking like that. What's acting like r here? Negative x over 2. Okay, so now let's write down our sum. So our sum then, and remember, all of this is equal to f of x, so I could say f of x then, in summation form, is 2 times, okay, this guy. This guy is the thing you want to write as the sum. So what's that going to look like? Just use this guy as your model and stick in your r that you came up with. So nothing changes with the sum. And then you guys already told me that r is negative x over 2, so instead of r to the n, negative x over 2 to the n. And we're not done yet. We haven't simplified this yet. We haven't made it look like the power series. So what do we want to make it look like? We want to make it look like this, except in this case, if a is 0, when a equals 0, it's more like sum n equals 0 to infinity of Cn x to the n, right? We want to make it look something like that. So how do we do that? Again, it's algebra. So we could do this. We could say this is equal to 2 times the sum n equals 0 to infinity. All right, this is a negative 1 factor in here, right? So I could break up the exponent over multiplication and division and make this negative 1 to the n times x to the n over 2 to the n. The exponent breaks up over multiplication and division. Now, if I leave it in this form, then you see the c sub n from the generic power series is negative 1 to the n over 2 to the n, and then times x to the n. So the c subscript n, that guy, is this guy. And it's important to be able to identify that later on. I'm satisfied with this representation, but there is another way to represent it. You could bring in this 2, and it'll be a factor on top. So 2 to the 1 on top. So what would that look like if we have 2 to the 1 on top and 2 to the n on the bottom? Well, you could think of it as like 1 over 2 to the n times 2 to the negative 1. What would that be? like bases, multiply bases, combine the exponents, 2 to the n minus 1. So you could simplify. So that's just a little bit of scratch work for you. You could simplify this guy as the sum n equals 0 to infinity, negative 1 to the n, x to the n over 2 to the n minus 1 because of this 2 on top right here. And then in that case, you'd be representing your c sub n as negative 1 to the n divided by 2 to the n minus 1, and you don't have that factor of 2 times the power series out in front. So that's your power series. Can you see how important it is to know your algebra here? More important than the calculus is, right? We haven't done any calculus yet. Now, we do need some values. Essentially, we want to write down the domain. Because remember, if you follow the equal signs, this thing's equal to f of x. This thing. But only for certain values of x. Only for certain values of x. So we need to talk about that. 75% view. Okay, so now we got a little more room here. So what was R again? I like how you said that. R, yeah. That's how the pirate does math. I don't know if pirates did very much math. What was R?
R was negative x over 2.
R, right, and then that has to be between what? For any of this to make sense?
Negative 1 and 1.
Negative 1 and 1. So you don't need the R there. You could just put that guy, what's acting like R, between negative 1 and 1. Then the algebra on this, you want to get x by itself to find the bounds on x. To find the x values you're allowed to plug in other words. The domain, if you like. So if you multiply through by, how about negative 2? What does that do to the inequalities? Flip some. If you multiply through by negative 2 to get x by itself, you'd have positive 2 is greater than x, which is greater than negative 1, but a better way to write that is have the smaller number on the left, so flip everything around. Negative 1 is less than x, which is less than 2. There's your interval. So, look, this is our answer. It's true, comma, as long as x is between negative 1 and 2, or if you like, you could use interval notation. We don't include the endpoints on geometric series. So. You don't need to test them either. It's a geometric series, so we know we're not going to get convergence at the endpoint. Oh, that should have been I see what you're saying. That should have been a negative 2. There we go. So it's an algebraic procedure. You're using laws of exponents, algebraic manipulation, no calculus involved though.